identifying similar or congruent shapes on a grid. So there's actually another video that's called identifying congruent shapes on a grid. So now we have to look at is it similar or congruent. So when we're looking at these, we need to know congruent and similar. What do they mean? So congruent means that it's the same size and shape. So not just the same shape, like they can't just both be circles, they both have to be the same size. Similar means it's the same shape, but can be different sizes. And by same shape, I don't mean like, I'm gonna draw this. Like here's one triangle, and then here's another triangle. Oh, they're both the same shape. They're both triangles. They're just different sizes. That's not what I mean. They have to be the same shaped triangle as well. So they can't just be random within the realm of the name of the shape. They have to be literally the same shape, but they can be different sizes to be similar. So if we scroll down here, this actually gives us more definitions. So congruent figures have exactly the same size and shape, just like I said. Similar figures have the same shape, but may have different sizes, and it says may. Congruent figures are similar figures because they have the same shape. So if we mark it as congruent, we should also mark it as similar, is what they're saying. So with this one, the two figures have different shapes, so they are not congruent and they are not similar. So in order to be congruent, remember, same size and shape. In order to be similar, they have to have the same shape. One's an oval, one's a circle. The two figures have the same size and shape. So if we weren't sure on this one, we could actually count it. So they both, there's a base of 1, and then let's go red for the next one. This is 3 tall, this is 3 long. So even though they took it and they turned it, it's still the same shape. So we would say it's congruent, and because it's congruent, it's also similar. So these two figures have the same size and shape. So again, we have this L figure. We go 3 down here and 3 over. So this one we go 3 up and 3 over. So even though, again, they turned it, it's still the same shape. You can still count it and see that. So we know it's congruent. If it's congruent, it's also similar. The two figures have different sizes, so they are not congruent. Right away, we know they're not congruent. But they're both squares. It looks like I could have taken the small one and just shrunk it down, or I could have taken the smaller one and blown it up a little bit, like kind of zooming in and out on the screen. You don't necessarily change the screen, you're just zooming in or zooming out, right? So then we can say that they are similar. So if you see down here, they just check the boxes that are true. And that's all we're going to do. So I need my cursor. Okay. Which pairs of figures are congruent? Which pairs are similar? So I'm not necessarily going to read that on every page because it's going to be the same exact directions. So on this one, we can see, and I hope you can see it too, this is the same shape. So we have this kind of L shape, but one's bigger than the other, so they're not congruent. So I'm going to check no. But they are similar because they are both this L shape. So I'm going to click yes for similar. It looks like I just took the big one and kind of shrunk it down, or again, took the small one and enlarged it or made it bigger. So these next two, these look like the same exact squares. And you can even look at that by going, there's 3 down, 3 across, 3 down, 3 across. Okay, that's the exact same square. So they are congruent. If they're congruent, they're automatically similar. All right, so this is actually one of the examples I gave you on the other page. These are the same shape or shape family because they're both triangles, but they're different shaped triangles. So not congruent and not similar because they're not actually the same shape. They're within the same shape family, but not the same shape. So be careful with that. All right, now we have a big circle, a little circle. Right away, I'm going to click no incongruent because they're different sizes. But every circle is similar to every other circle you've ever seen. So like this circle actually is congruent to my color circle over here, which, not congruent, sorry, similar. Similar to the color circle, and it's similar to this little bullseye circle that I have on top of it. And then it's similar to this little dot circle over here. So all circles are similar. So we click yes and check. And we get a point. All right, we're going to do this a couple more times here, and I'm going to clear because I did write on that one. Okay, so we have a rectangle and a rectangle. Different sizes, so not congruent, but they are similar because they're both rectangles. Let's see. We have triangle, and it does look, because we have, and with this one, what you want to make sure is it was 4 to 2. So I didn't really explain why they were similar real quick. So we have 4 to 2. And then we have 2 to 1. So I divided both sides by 2. So I shrank both sides at the same rate. That's another thing you want to make sure, that not every rectangle is similar to every other rectangle like circles. So you do need to make sure that they reduce at a similar rate or enlarge at a similar rate. So with this one, I have 3 and 3. I know it's not congruent because they're different sizes, but I want to make sure. So this goes 1 to 1. Well, 3 to 3, if I divide both sides by 3, I get 1 and I get 1. So that does work. So we just want to make sure that the similarity matches. Okay. Excuse me. We have this L shape. We go down 3, we go to the right 3, and this one we come over to the left 3 and down 3. So they are the same kind of corner shape there. They're turned. So they are congruent, and when they're congruent, they are automatically similar. These are different shapes. One's oval, one's circle, so not congruent, and, oops, sorry, not congruent, not similar. I almost clicked yes there. All right, one more. Clear. All right, so we do have the same T shape here. So they do look like the same shape. And if I count this across, I get, let's see, 1, 2, 3, 4, 5, 6 across. I get 2 here. And I could go all the way around if I wanted. It's 2, 2, 2, 2, 2, like this. So there's a bunch of 2s. So with this one, I just want to make sure that when it reduces by a similar amount on all the sides. So I have 3 on the top, 1, 1, 1, 1, 1. So if I divide everything up here and the big one by 2, I get 3, and I'd get a bunch of 1s. Oh, look at that. That's exactly what I have. So I know that this is a similar shape, but they're different sizes, so not congruent. These two triangles are congruent, it looks like. So I have a base of 2, a base of 2, and then 1, 2, 3, 4 tall, 1, 2, 3, 4 long. So those are in fact congruent, which makes them similar. All right. With this one, we have a rectangle and a square. So those are different shapes, so not congruent or similar. Circles, so we already talked about this. All circles are similar to each other, but they have to be the same size in order to be congruent, and those are different sizes. So check. And we finished another one. Yay! There, next.